Hey Dr. David, how are you doing? This is my video essay response for Chapter 8. The essay is ciprofloxacin, erythromycin, and acyclovir are used to treat microbial infections. Ciprofloxacin inhibits DNA gyrase, erythromycin binds in front of the A site on the 50S subunit of a ribosome, and acyclovir is a guanine analog. Your first question is, what steps in protein synthesis are inhibited by each drug? Starting with ciprofloxacin, which inhibits DNA gyrase. DNA gyrase relaxes supercoiling ahead of a replication fork. With DNA remaining supercoiled, replication and transcription cannot take place because of a replication fork has not been formed. In addition to this, DNA and RNA polymerase cannot begin replication and transcription if not uncoiled, and there is no replication fork dividing the double helix. Secondly, erythromycin binds to binds to the front of the A site on the 50S subunit of a ribosome. Ribosomal subunits allow for the amino acids and its anticodons in tRNA to pair with the codons on the mRNA and the P and A sites, as well as form peptide chains at the P site. The A site in this case, is where subsequent tRNA will prevent the anticodons from pairing with their respective codons and prevent the peptides from binding to form a peptide chain. A blocked A site will stop translation from occurring because of falling tRNA will not be able to fill the site to allow for the peptide linkage to occur. And lastly, acyclovir is a guanine analog. A guanine analog allows for the same sequence of DNA nitrogenous bases whilst changing the guanine nitrogenous base itself. The alteration in nitrogenous bases can result in a mutation, and guanine is replaced with an analog, in this case, stopping DNA replication altogether. And due to the lethality of mutations, the mutation of the DNA strand, as a result of the guanine analog, can lead to cell death. Your second question is, which drug is more effective against bacteria and why? The drug I believe is the most effective is ciprofloxacin. It inhibits DNA gyrase from uncoiling supercoiled DNA, which is the first step in order to do DNA replication. And thus, if the first step in DNA replication is prevented, then none of the following steps can occur. Your third question is, which drugs will have effects on the host cells and why? I believe all three drugs affects the host cells because they cannot differentiate between host cells and bacterial cells, but they will all do what they're supposed to do regardless of the cell type. And your last question is, use the index of our book to identify the diseases of acyclovir is primarily used. Why is it more effective than erythromycin for treating this disease? I'll be honest, I do not have the textbook, but after doing some searching, I believe that herpes is a common disease that acyclovir is primarily used for. Acyclovir is more effective than erythromycin because it stops production of replicated DNA, while erythromycin just prevents the peptide chains from forming. And in order for a virus to be stopped, DNA replication must be stopped. Thank you.